Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 5 from the course, but make sure you watch the previous ones before viewing this one. In the last lecture, we discussed the atomic models given by Thomson and Rutherford. And now, during the discussion of the Rutherford model, we discussed quite a lot about the nucleus, the presence of the number of protons, the neutrons, and then around the nucleus orbiting electrons. So we will study a bit more about these electrons, protons, and neutrons in the topic the atomic number and the mass number. So what is basically atomic number? You can understand this by Moseley's law. And what is Moseley's law basically? Well, I hope you all remember during the class 10th you studied the periodic table, and in that you studied about Mendeleev. And what did he do? Well, he arranged all the elements in increasing order of the atomic masses. Now, Moseley, after his experimental analysis, found that the nuclear charge increases by 1 unit in passing from one element to the next when the elements were arranged by Mendeleev in the increasing order of the atomic masses. And this increase in nuclear charge was due to what? Yes, it was due to the increase in the number of protons in the nucleus. So, the number of positive charges carried by the nucleus of an atom is called as the atomic number of the element. And hence, we can define the atomic number in many ways. It is denoted by the symbol Z, and it is number of unit positive charges present on the nucleus. Or you can say that the atomic number is the number of protons present in the nucleus. It is even equal to the number of electrons present outside the nucleus of the same atom. And the atomic number of each element, please remember, is characteristic. No two elements have the same atomic number. Hence, the atomic number of each element is its fundamental property. And the atomic number, one more important thing is that the atomic number of the element is equal to the number of electrons only in a neutral atom. Right? So we said that the atomic number of the element is equal to the number of electrons orbiting outside the nucleus. So it is only the case when the atom is neutral. Now, what is mass number? So the mass of the electrons we have already discussed is negligible when compared to the mass of protons and neutrons. So the real mass of an atom is due to protons and neutrons, and hence we say that the total number of protons and neutrons present in the nucleus of an atom is called its mass number. Mass number is equal to the number of protons and number of neutrons. If we denote the mass number by A, the number of protons by Z, so A is equal to Z plus number of neutrons. Or we can say the number of neutrons is A minus Z. And how do we denote the atomic number and the mass number? Well, first of all, we write the symbol of the element. For example, we say this is X. Okay. So we write the atomic number as the subscript and the mass number as the superscript of the symbol. For example, we have O816. So 8 is the atomic number as 16 is the mass number. For chlorine, 17 is the atomic number, 35 is the mass number. Calcium 20, 40, the 20 is the atomic number and 40 is the mass number. If you remember, in the last lecture, we discussed about nuclear size and density a bit in the lecture and some things in the have an edge section. So the nuclear size and density, these points have been mentioned in the NCERT textbook also. So let us just quickly revise them before moving further. So the nucleus of an atom is very small as compared to the size of the atom. You know that the nucleus is composed of protons, the neutrons. Hence, the size of the nucleus should be proportional to the number of nucleons. And we have a relation r, the radius of the nucleus, is equal to r naught a 1 by 3, where r naught is a constant with a value ranging from 1.3 into 10 power minus 15 meter to 1.5 into 10 power minus 15 meter, and a is the atomic mass. This is an important relationship between the atomic mass of an element and the radius of the nucleus. So please do remember it. Now the radius of the nucleus, this is going to range from 1.5 into 10 power minus 15 for a proton. Why so? Because if you take the value of r naught to be 1.5 into 10 power minus 15, the atomic mass of a proton, that is the hydrogen atom, to be 1, you will be getting the radius to be 1.5 into 10 power minus 15 meter. And this goes up to about 6.5 into 10 power minus 15 meter for one of the heaviest elements. And then this is much smaller a number than the atomic radii, which is 10 power minus 10 meter. Many a times these questions have been asked. The values of the radii of the atom, the values of the radii of the nucleus. So please do remember these figures. And the nuclear radii, they are generally expressed in Fermi, where 1 Fermi is 10 power minus 13 centimeter or 10 power minus 15 meter. And now if we assume the nucleus to be a perfect sphere, the nuclear volume is also going to vary directly with mass, because we know that the radius is 4, radius and volume, they are directly proportional to each other, the volume being 4 by 3 pi r cube. So now the volume is also going to be related to the mass number in relation to this relation. Fine. So we have V proportional to the mass number, or we can say that the mass of the nucleus depends upon the volume 4 by 3 pi r cube, and the nuclear density m by V is therefore going to be constant for all atomic nuclei. The mass of a proton is 1.672 into 10 power minus 24 gram. Its volume is 1.5 into 10 power minus 38 centimeter cube. Hence, the nuclear density, if we are going to calculate, which is mass by volume, it comes to the order of 10 power 14 gram per centimeter cube or 10 power 8 tons per centimeter cube. So I hope this all information is clear to you. Please do remember all of this. Okay, now we have nuclides. What are nuclides? They are the species of an atom characterized by the composition of its nucleus in terms of number of protons and neutrons. One of the nuclides being isotopes. What are isotopes? They are the atoms of the same element having identical atomic number but different mass number. And the difference is due to the difference in the number of neutrons. Why is the mass number different? Because we have different number of neutrons. And because the properties, the chemical properties of an element depend upon the atomic number, they have similar chemical but different physical properties. Okay, so we have an example of the isotopes of hydrogen. We have the first isotope protium, which has the formula H11. The mass number is 1, the number of protons is 1, and the mass number minus the number of protons is going to give you the number of neutrons, which is 0. Then we have the other isotope, deuterium, which is H12. This is denoted by the symbol D. It has mass number 2, the atomic number or the number of protons to be 1, and the number of neutrons to be 1. Then we have tritium, H13. So this has the mass number 3. Number of protons again 1. So you can see all having the same number of protons or the same atomic number, and the number of neutrons to be 2. So the difference is in the number of neutrons. Another example is of the isotopes of oxygen. We have an isotope of oxygen with the mass number 16, 17 and 18. The number of protons for all of them is 8, and the number of neutrons is different because the number of neutrons is mass number minus the number of protons. O16 will have number of neutrons to be 8, 17 has 9 and 18 has 10. So I hope you are clear with the isotopes, that the isotopes, they are the atoms of the same element having identical atomic number but different mass number. Now, have you seen these terms written somewhere earlier? Yes, we have done this while we were discussing some basic concepts of chemistry, lecture number 3. Okay, so what we discussed there was that the atomic masses, they are fractional in number, right? What is basically the difference between atomic mass and mass number? Mass number is for an individual atom basically of the element, where we have the mass number to be the number of protons and number of neutrons. And when we say atomic mass, it is actually the average of the atomic masses or the mass numbers of all the natural isotopes. Okay, so there, while we were discussing the atomic masses to being fractional, we found why they were fractional. So we have the relative abundance of the isotopes. All elements, they are a mixture of isotopes. The percentage abundance of these isotopes is different, and hence the atomic masses are different. So what atomic mass is what? It is the summation of the fractional abundance of each isotope multiplied by the mass number of that isotope. Okay. And then how do we calculate the fractional abundance? That would be the percentage abundance divided by 100. Right? So the percentage abundance of each divided by 100 multiplied by the mass of the isotope. Then the second percentage abundance divided by 100 into the mass of that isotope. And then we take the average of all this, and then we find the atomic mass. If there is some confusion, please do see lecture number 3 from the course Some Basic Concepts. There we have discussed this in detail, and then we have done a few numericals based on this also. Now the next thing we have is the isobars. What are isobars? Well, they are the atoms of different elements, not the same elements, having different atomic number. Because the atomic number is different, so the element has to be different, because we have said that the atomic number is the characteristic of each element. Fine. So we have different atomic number, but the mass number is same. And isobars, they have different number of therefore electrons also, protons also and neutrons also. They have different physical and chemical properties because the number of protons is different. So for an example, we have argon 1840, potassium 1940 and calcium 2040. All of these have the same mass number 40. The atomic number of argon is 18, potassium is 19, calcium is 20. The atomic number and the number of electrons is same. So the number of electrons 18, 19 and 20. Atomic number is nothing but the number of protons. Hence we have number of protons in argon to be 18, potassium to be 19 and calcium to be 20. And now how do we calculate the number of neutrons? Yes, it is the mass number minus the atomic number. what do you get as the number of neutrons for argon 22, potassium 21 and calcium 20. So the number of protons is different, the number of electrons is different, the number of neutrons is different. What is same? The mass number. Next we have isotones. So what are isotones? They are atoms of different elements. So different elements means the atomic number is going to be different. Then this contains the same number of neutrons. They are called as isotones. These are atoms of different elements. Hence they are going to have different physical and chemical properties. For example, we have sulfur 1636, chlorine 1737, argon 1838, potassium 1939 and calcium 2040. Okay, so you see here the atomic numbers. Sulfur is 16, chlorine is 17, argon 18, potassium 19, calcium 20. The mass number: sulfur 36, chlorine 37, argon 38, potassium 39 and calcium 40. Subtract the atomic number from the mass number, you get the number of neutrons in all of them to be 20. So such atoms of different elements which have the same number of neutrons, they are called as isotones. So let us see a difference between the isotopes, the isobars and the isotones. What are isotopes? Atoms of the same element having same atomic number but different atomic masses. Then we have isobars, atoms of the different element with different atomic number but same mass number, and isotones having the same number of neutrons, right? Different atomic number, different mass number, only the number of neutrons is the same. So we have isotopes to be having the same number of electrons and protons but different number of neutrons. Isobars, they have different number of electrons also, protons and neutrons. And then isotones, the number of electrons and protons is going to be different but the number of neutrons is the same. For isotopes, the properties, because they are atoms of the same element having the same atomic number, so they have similar chemical properties, but the mass number being different makes the physical properties different. Isobars, different elements, so different physical and chemical properties. Isotones, again different elements, so different physical and chemical properties. Next we have the isoelectronic species. These are the atoms or ions having the same number of electrons. For example, O2 negative, Na plus and aluminium plus 3. They are isoelectronic as these contain 10 electrons each. So let us see how. We have O2 negative. Oxygen has the atomic number 8. So the number of electrons in the neutral atom would also be 8. But we have not oxygen, but we have O2 negative. 2 negative means that oxygen is an anion, and anion is formed by the gaining of electrons. So 2 negative shows that this oxygen has gained 2 electrons. So 8 plus 2, now we have 10 electrons. Now sodium plus, okay, so the atomic number is 11. So for the neutral atom, the number of electrons are also 11. But plus here means that this is a cation. A cation is formed when a neutral atom loses electrons. So sodium plus 1 means it has lost 1 electron. So 11 minus 1, it has 10 electrons. And similarly, aluminium plus 3, the atomic number is 13. The number of electrons in the neutral atom would have been 13, but because it has lost 3 electrons, it has 10 electrons. So now these all having the same number of electrons, they are isoelectronic species. It is not only in the case of single atoms, the ion can be formed by the union of atoms of different elements also. We have nitrate ion, we have carbonate ion. Try calculating the number of electrons in them. you will find them that they are 32 in case of both of them. So these two are also be isoelectronic species. Then the next term we have is isodiaphers. Now what are isodiaphers? They are the atoms of different elements having the same difference of number of neutrons and protons. For example, we have boron and carbon. So boron has 5 number of protons, it has 6 neutrons, and number of electrons equal to the number of protons is 5. Now if you see N minus P, that is the neutrons minus the protons, this is what? This is coming up to 1. For carbon, the number of protons is 6, the number of electrons is 6, the number of neutrons is 13 minus the 6, 7. So now you take the difference between the number of neutrons and the number of protons, you get this as 1. So the atoms of different elements who have the same difference of the number of neutrons and protons, they are called as isodiaphers. So now let us do a few numericals based on these terms. I hope all this is very clear to you. These all definitions are very important. So the first numerical we have is that an atom of an element contains 29 electrons and 35 neutrons. You have to deduce the number of protons, the electronic configuration of the element, and the mass number. So we have the number of electrons to be 29, the number of neutrons to be 35. For the neutral atom, the number of protons would be equal to the number of electrons, right? So the number of protons is equal to 29. The atomic number therefore is 29, and hence this element is copper. The next question asked is about the electronic configuration of the element. You will see the electronic configuration written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3p10. Okay, so you may not be able to understand this, but you will be by the time we finish this course. Okay, so just to have a glimpse of what all we are going to do in this lecture, this was added to the question. Do not worry, you do not know till now how to write the electronic configuration, but you will be able to. And then we have the mass number, which is the number of protons and the number of neutrons. So this is going to be 29 plus 35, that is 64. So I hope at least you can calculate the number of protons and the mass number from this question. So the next question says calculate the number of neutrons in the di-positive zinc ion, that is Zn plus 2 and Mg plus 2. So for the first we have zinc, the number of protons being 30 because the atomic number is 30 and the mass number is 65. So you will have the number of neutrons from the relation that number of protons plus neutrons is 65. So you get the number of neutrons to be 65 minus 30, the number of protons, and hence the answer being 35. The next we have magnesium. So the number of protons equal to the number of equal to the atomic number being 12. The mass number is 24. So the number of neutrons is going to be 24 minus 12. So this would be again 12. The point to remember here is that whether it is the ion or the neutral atom, the number of protons and number of neutrons is going to remain the same. There is not going to be any difference over here. So now let us see another example. So the question says that calculate the total number of electrons present in 1.6 gram of methane, the atomic mass of hydrogen being 1 and that of carbon being 12. So you know that the molecular weight of methane, how we are going to calculate it? This is going to come up to 16 AMU and the gram molecular weight being 16 grams. Now 16 gram of methane make how many number of moles? That is 1 mole. So 1.6 gram of methane will make how many number of moles? I think this is all very easy for you now. You have done the whole of mole concept. So this is zero point 0.1 moles. And 1 mole of methane is how many molecules? 6.02 into 10 power 23 molecules. And 0.1 mole of methane is going to be 6.02 into 10 power 22 molecules. Now, you know that one atom of carbon consists of 6 electrons and one atom of hydrogen contains how many electrons? 1. So, the total number of electrons present in one molecule of methane is going to be 10. 6 of carbon and 1 into 4 for the hydrogen, CH4. Okay, so this is going to make it 10 electrons per molecule. And we have how many molecules? 6.02 into 10 power 22 molecules. So the 6.02 into 10 power 22 molecules of methane will have how many electrons? 6.02 into 10 power 23. So I hope this is clear to you. The next question says an ion with mass number 37 possesses 1 unit negative charge. If the ion contains 11.1% more neutrons than the electrons, find the symbol of the ion. So let us assume the number of electrons in the ion to be X. The number of neutrons, which is 11.1% more than the number of electrons, is going to be X plus 11.1% of X. And this is going to be 1.111x. Now the number of electrons in the neutral atom is going to be X minus 1. Why X minus 1? Because the neutral atom, it has gained 1 electron to form the ion. Okay, so the number of electrons in the neutral atom, you can say this is going to be X minus 1. And the number of protons is equal to the number of electrons in the neutral atom. So this is also going to be X minus 1. And the mass number is the sum of protons and neutrons. So this is going to be 37 equal to 1.111x plus X minus 1. Now you can solve this for X to be 18. And now this 18 is the number of electrons present in the ion and not the neutral atom. So the number of electrons equal to the number of protons in the neutral atom is going to be X minus 1. That is 18 minus 1 or 17. So we have the symbol of the ion, that is the chloride ion. The chlorine has atomic number 17. So the chloride ion is also going to have the atomic number 17. The mass number is already given to you to be 37. So this is how it is represented. Chlorine with 1 unit negative charge, atomic number written as the subscript and mass number written as the superscript. So I hope this is clear to you. Now the next question says that if the mass of neutron is doubled and the mass of electron is halved, find the atomic mass of C612 and the percentage by which it is increased. So we have carbon C612, which means it has 6 electrons, 6 protons and 6 neutrons. The mass of the atom is contributed by the protons and the neutrons. So the 12 mass number is going to give 6 AMU protons and 6 AMU neutrons. And now we have in the question that the mass of the neutrons is doubled and mass of electrons is halved. So we have the mass of neutrons to be 6 into 2, that is 12 AMU. But the mass of protons, nothing has been done to it. So the mass of protons is going to remain 6 AMU. And the sum of the mass of neutrons and protons, this is going to be 12 plus 6, that is 18 AMU. Remember that the mass of electron is negligible. So even if we half it or we double it, it is not going to matter. We are not going to consider it in the calculation of the atomic mass. Now the percentage increase in atomic mass is going to be final mass minus initial mass over the initial mass into 100. So we get this as 18 minus 12 divided by 12 into 100, that is 50%. So now I hope you have had an interesting time learning so many new names, the isotopes, the isobars, the isotones, and so forth. Now let us have something in the Havenage section also, where we have two more interesting terms for you. First are the nuclear isomers. Well, atoms of the radioactive elements having the same atomic number, same mass number, but different radioactive properties are called as nuclear isomers. For example, we have uranium X2 and uranium Z, which are found in the uranium-radium decay series. And the difference in the nuclear properties is because of the different arrangement of protons in the nuclei, right? So nuclear isomers, they have the same atomic number also, the same mass number. The radioactive properties are different. And then one more term, isosters. What are they? They are the molecules of different substances that contain the same number of atoms and the same number of electrons. The presence of same number of atoms and electrons leads them to have similar properties, right? So we have carbon dioxide and we have N2O. So carbon dioxide also has 3 number of atoms and N2O also has 3 atoms. If you calculate the number of electrons in both of them, they are also going to be the same. Okay. So such molecules which are having the same number of atoms and same number of electrons also, they are called as isostars. So that would be all for this lecture. I hope you really had a nice time learning these interesting terms. And if you've liked the lecture, please do click on the like link and also do subscribe to our channel so that you get a notification as and when we put up a new lecture for you. Click on the like link, click on the subscribe link, and also on the bell icon. So that would be all. If you have any difficulty in understanding anything, you have any suggestions to give to us, please do mail us at h2ochemistry@gmail.com. We would meet again for lecture 6 on the topic electromagnetic spectrum from the course The Atomic Structure on the channel H2O. Bye for now. Have a nice day. Enjoy yourself.